Today we're going to start our study of right triangle trigonometry. So grab a pen or pencil and make sure that you take notes. Why trigonometry? Well, trigonometry uses ratios of sides and angles to determine missing sides or a missing angle within a triangle. We will use trig to find a missing side or a missing angle of any right triangle that we want. As long as we have a few other things present, we can do this. What's important to know about right triangle trig is you have to be able to label your sides. There's one side that will always have the same name regardless of what angle we're working with, and that's the hypotenuse. The hypotenuse is always across the triangle from the right angle, okay? Same as when we're working with Pythagorean theorem or our special rights. So this is called the hypotenuse. And then the other two sides are labeled depending on what angle we're working with. If we're working with angle A, or we're working with angle B. So let's say I want to work with angle A. I'm going to mark that angle. Then I'm going to label my adjacent side and my opposite side. Okay? We know the word adjacent means right next to, so that's the side that is next to the angle that we just marked. And then we have the opposite side. The opposite side is the side that is opposite the triangle from the angle we're working with. So there you have the labels of the names. Now, if I was to change and we were to look at angle B, the adjacent and the opposite would change places because adjacent means next to, and that means it's next to the angle. So the trig ratios that we're working with, there's only three that we actually work with. We'll work with the sine ratio, which is the ratio of the opposite side over the hypotenuse. This is the button on the calculator. The cosine ratio, which is the adjacent side over the hypotenuse. This is the cosine button on the calculator. And then you have your tangent ratio, which is your opposite side over your adjacent side. And this would be the tangent button on the calculator. Now, there's a few steps to finding trig ratios. First thing, you want to label the hypotenuse of the right triangle. And then you're going to check the question and look and see what angle are you using. Then you're going to highlight or mark the acute angle you're using. Then you're going to label the legs in relation to the acute angle. So remember, this label changes depending on the angle you're working with, the opposites and the adjacent sides. Next, you're going to circle the sides you're supposed to use to make the trig function specified to you. If you're using sine, I want you to circle the opposite and the hypotenuse. Cosine, you're going to circle adjacent and hypotenuse. And if you're using tangent, you're going to circle the opposite and the adjacent. Then you need to decide which goes on top in the numerator and which goes on bottom in the denominator. Write the fraction, and if needed, you need to reduce it. This is how you find the ratios. Look at our first example. Find the sine of A. Well, our first step is to label the hypotenuse, and if you remember, the hypotenuse is across the triangle from the 90-degree angle. So that's our hypotenuse. And then we're going to check our question and see what we're working with. We're wanting to find sine of angle A. Angle A is very important to us, so that's the angle we're working with, and that's what we're going to mark. So now that I'm working with angle A, I know that sine is opposite over hypotenuse. I need to label my other sides. Remember, the adjacent is right next to the angle. The opposite is across the triangle from that angle. Now I'm going to circle the opposite and the hypotenuse because those are the numbers that I'm going to need, and we make our fraction. The sine of A is equal to my opposite, which is 5, over my hypotenuse, which is 13. So that's the ratio. Let's look at example 2. Find the cosine of b. Start by labeling our hypotenuse. Cosine is adjacent over hypotenuse. Okay, we're working with angle B, so I'm going to mark that angle. I'm going to label my sides. My adjacent is right next to my angle. My opposite is across the triangle from my angle. From what we looked at earlier, cosine is adjacent over hypotenuse. So I need the adjacent. I need the hypotenuse. So the cosine of angle B is my adjacent side, which is 5, over my hypotenuse, which is 13. In our example, looking at tangent A, we have hypotenuse. We're working with angle A. And tangent is opposite over adjacent. So I'm going to label my other side. Adjacent. Opposite. Circle the sides I'm using. I'm using my opposite. I'm using my adjacent. So the tangent of angle A is my opposite, which is 10, over my adjacent, which is 24. Okay? If you look at this, 10 over 24 can be reduced. Both of those can be reduced by 2. So my tangent of A is 5 over 12. There's a way that you can remember the ratios and what sides go with what. We've talked about SOHCAHTOA. Okay. In the past, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. We've talked about the chart. I've shown many of you the SCT chart that I always make. And then I say Oscar has a heap of apples, so a mnemonic device you can use. Whatever you want to do that helps you know the order that they go in, you can use. So, SOHCAHTOA is a really popular one, so is OA or Oscar has a heap of apples. So, good luck. Make sure you finish your homework and bring it to class tomorrow, and I will see y'all tomorrow.